Well, we're in for a treat today. A good friend of mine, Dr. Robert Potok, is joining us today to talk about something that we've all experienced, but we really don't know where it comes from. And it's the idea of consciousness. Rob holds a Doctor of Science degree from MIT. He worked at Bell Labs, and then after the split up, he ended up at AT&T Research Lab. And he was telling me that he worked in both the science of science and the science of marketing. And whereas in science, there is the possibility of understanding fundamentals, when you get to the science of marketing, he may have to correct me on this, but it doesn't follow any logic. So it's a challenge. So it makes it difficult to analyze. I think consciousness is sort of in the same ballpark to me, but I'll let him explain. Rob, come on up.
Good morning, everyone. The topic for today is entitled Shadows of the Mind. It is a missing science, but there are shadows that we can look at, just like we can't see the issue clearly, but we can see some of the effects and derive implications from those effects. So let's see, thank you. Also want to highlight a book where a lot of the thoughts for this talk are coming from. It's a book by Roger Penrose, Shadows of the Mind, The Search for the Missing Science of Consciousness. This was published in the 1990s, was on the New York bestsellers list. And every time I'm referring directly to what's in this book, I will try to remember to give credit to Dr. Penrose. There we go. So this is directly from Roger's book with a few word modifications. So the physical basis of consciousness, what could it possibly be? Or it doesn't even exist. The strong AI conjecture is that consciousness is a product of computational ability, and a computer with enough processing power would be conscious. The weak AI theory or conjecture is somewhat similar, that you may have consciousness being non-computational, but all the implications, all the abilities can be emulated on computers. In 1950, Alan Turing proposed the imitation game, that if a person could be interacting and having a conversation where the nature of the conversant was hidden, but you can only communicate back and forth, if a computer could be at a level of a human conversation, and the person doing this conversation could not tell whether he was conversing with a computer or another human being, that would be the evidence for the existence of a mind. It wasn't really clear whether Turing was talking about one or two. I mean, it sounds like he's talking about number one, but maybe the concept of one versus two, the weak or strong AI conjecture, really hadn't been developed yet. A subtle hint of which possibility I'm in favor of, subtle hint on the view screen. That is number three. The consciousness is a physical process that is fundamentally different than computational endeavors, and you can never simulate all the abilities of a conscious mind. And possibility four is that there is some non-physical component to consciousness that you could never explain from physical effects. So that seems to cover all possibilities. And this talk is a combination of psychology, mathematics, computer science, and quantum physics, bringing all these different fields together to try to come up with a pointer to what's probably the right answer. So, the principle of ownership. If you own a decision, then you own the result of that decision. And two worldviews, a proactive and a reactive worldview. In a proactive worldview, you own your decisions and you own the results of your decisions. And a reactive worldview is you let other people and things own your decisions, and then you can blame those people and those things for the results of your decisions. Who hasn't heard a kid say, "You made me angry, look what you made me do." And maybe some adults, unfortunately, are like that too. But if you adopt a proactive paradigm, your response to the world around you can be anything you want it to be. And why not just pick the path that brings you the most value? Not just run your life out of your feelings, which is the psychologist debate in a past age of whether it was nature or nurture that made people what they are. And unfortunately, they didn't think of other possibilities for the choice. In terms of it's your nature to be the way you are, all four of my grandparents are hot-blooded, quick-tempered people, and of course, I am thus hot-blooded and quick-tempered. It's their genes you're talking to. If you've got a problem with the way I'm acting, go talk to my four grandparents. And of course, my four grandparents each had four grandparents, so by induction, the first monkey to stand on two legs has a lot to answer for. Moving down the line to nurture, my parents raised me to be like this. They've instilled these habits in me, talk to my parents if you don't like the way I'm acting. And then finally, I think, the final choice is I am in charge of me. It's not my grandparents, it's not my parents. Nurture and nature can have profound influence on you, but if you're a sane person, you're accountable for what you're doing. If you have a problem with the way I'm acting, come talk to me. A little bit of the history of computer science here. A couple definitions for the talk too. When I use the word mathematics, I mean the logic of certainty. And statistics, I mean the logic of uncertainty. Mathematics came into being much earlier than statistics. It was a missing piece of the ability of people to understand the world around them until the Renaissance. The history of mathematics goes back much further. Excuse me for a second. So in the history of computer science, there have been two invariants. There's been algorithms and there have been data. And what's evolving is the relationship between them. Pre-1970s, we have procedural programming where algorithms were quoted as functions that would process data. Starting in the 1970s, we have the addition of object-oriented programming, where data is abstracted and algorithms are created as public interfaces to let the data structures interact with each other. I can dive into that in a question and answer period, maybe if you want more detail on how that works. Starting in the 1990s, I estimate that we got into deep learning, synergistic progressions of algorithms and data transformations. Neural network is one example of a deep learning technique. And then, up to the current day, we have AI, large language models, and coming soon, large action models that can regurgitate big data in creative and useful ways. And an example of this is also the dawn of quantum computing. We're right at the very beginning of this. An example would be SNDL, store now, decrypt later. The quantum computers are not powerful enough to break the internet quite yet, but they're coming close. So people are already engaging in storing massive amounts of internet traffic with the hope of someday being able to break the code and see what's in there. And there are efforts to figure out how to solve this problem. Public key encryption is one of humanity's greatest achievements, and we may have to abandon it. Deep learning. Many cycles of transformation of the data. You have datas and algorithms, and maybe two common ways of dealing with it. One is a Hadoop paradigm, where you have distributed hardware and software. You get reliability through cheap redundancy. You just spread out your data with mirrored copies on a vast array of cheap computers. And you push the algorithm to the data with a central star in this very simple one layer of hierarchy, a master node and all these servant nodes that work on pieces of the data. And the paradigm is you share nothing between the nodes, everything goes to the master location. Versus if you want to look at comparing individual observations with each other, you need an inter-observation paradigm where you share everything that's useful to share, ability to outer product the data in a time series, and I've got a backup slide if we have time to talk about that. And the ability to investigate the functional relationships among the different attributes and your goodness parameter. If you think of a regression model, you've got this attribute and you're trying to calculate a coefficient for it. How much weight do I give this attribute in my regression model? There's much more to be learned if you actually think of looking at the functional relationship between that attribute and the other attributes and the goodness parameter you're trying to predict. It's more complex, but you can get into knowledge that you can't get with regression techniques. And here I'm defining the difference between computable and understandable. This is the great mathematician Hilbert's 10th problem is you want to create an algorithm that can take a finite set of polynomial equations with a finite number of terms with integer coefficients and integer powers, and in a finite number of steps, no matter how long those steps are. Is there an integer solution to all the variables to satisfy the equation set? I've got up here just a simple example of two equations that there can be no integer solution because one implies x must be an odd number and the second one implies x must be even. And there is a proof in number theory that you can have no algorithm that has this ability. That's described at the top of the slide. The problem is understandable, but it's not computable. And for the difference between algorithms and ideation, I just want to go over a simple, basic algorithmic structure to play a board game. I put the word chess here, but you can easily just substitute the word checkers or reverse or any two-player board game would have this basic structure of needs. One is you need a routine to take a board position and maybe the history of play and generate moves for a player. I mean, you can't have a computer program play a board game if it doesn't know what the next move is. So you need a way of generating successors. You need some basic bookkeeper to keep track of the decision tree that you're creating of I move, you move, I move, you move. You need some logic to descend into trees. And at the end of the search tree, you need a way to evaluate the position. Is this good for the alpha player versus the beta player? So come up with a number, or the higher the number, the better it is for alpha, and the lower, the better it is for the second player. So the way computer learning would work is you have two different static evaluation functions. You let them play millions of games with each other, and you take the knowledge of those games to try to improve the static evaluation function. I mean, maybe one function does better in open positions, one does better in closed positions, one does better when it has an advantage of materials, other does when it's actually trying to come from behind. You can imagine all the different possibilities of what you could be looking for in terms of refining a new algorithm to try and new algorithms to try as improvements. So, this is machine learning. But the difference between this and ideation is, I mean, you could run this algorithm and, get a better chess playing program, but it's not going to come up with new ideas on its own of how to attack the problem. You define the attack process in your algorithm, but a new idea would be not just to use the static evaluation function at the end of the decision tree, but to use it along the entire path and take a look at the curve that you're creating as a function of time in terms of how well the position's evolving. So, at the top curve is maybe a best move. You've got a good advantage, but it's not going anywhere. You don't see a path for actually improving your score. Where a nice better move, which would probably even surprise your opponent because it looks like it's a terrible move, but in your search, you actually see it turning around and shooting back up and getting you back into at least an even game, and maybe with some chances of winning, but it's not rated as highly at the vision, the limit of your vision, the event horizon, the depth of your tree search. But doing this technique, you might want to think about taking this even better best move, even though it's ranked with a lower value. But that's an idea, that's ideation. Your algorithm is not going to come up with this idea by itself because you haven't coded this idea into your algorithm. Algorithms don't create ideas. They just sort of converge. The learning process is a convergence. Just like if you had a Newton-Raphson interpolation scheme to find the roots of an equation, you can say the algorithm has learned what the solution is, but is that a function of a mind? I would say no. I'd say it's a function of a converging algorithm. Ideation, coming up with new ideas, is fundamentally different than algorithmic convergence. Okay, switching over to the quantum magic. This is also from the book of Roger Penrose, and it describes the existence of counterfactual observations. This was done by Alain Aspect in around 1979, 1980, in experiments in France. of proving something that was there in the quantum electrodynamics, the quantum theory, but was so unusual and unexpected that they actually just did the experiment to see if this really happened, and then the results were it really did. The existence of a counterfactual observations. What you're seeing here is a single photon is released, and this is a symbol for a half-silvered mirror, so the photon has a 50% chance of being transmitted or a 50% chance of being reflected. These are 100% silvered mirrors. And you come back here finally to a half-silvered mirror. And if you tune your optical bench with this experiment, you're 100% of the time, the photon will be detected in detector F because you have destructive interference with the two possibilities of going down path B and C. It's also, the implication is a single quanta, and it's subjectively undetermined whether the photon was transmitted or reflected. It's one quanta of particle. It doesn't like half the photon goes one way and half the other. That's not what's happening. It's subjectively undetermined which way the photon is going. Both probabilities are propagating into the future. In the quantum world, the past is objectively undetermined, which is very counterintuitive, but one of the predictions of QED, and the experiments are validating that mathematics. What you can do is put a measurement device here that can detect whether the photon has been reflected. And once you do that, you've broken the probabilities. You've actually forced the quantum system to decide which probability has occurred. There's no more destructive interference, and 50% of the time you'll get it, the photon measured in detector F, and 50% of the time measured in detector G. Whether or not you actually detect the photon here or not. So this is what's called a counterfactual observation. The fact that you've made a measurement and proved that it did not go down this path. You've actually changed the state of the quantum system, and there's no more possibility of destructive interference between the two probabilities. There's no classical analogy. There's no analogy to this in classical physics. To make a measurement of something, you have to interact with it. Not so in a quantum. You know, the fact that you can measure where it is not can actually change the system. And that's that idea of an undetermined past at the quantum level, and the fact that a non-event could actually influence the system. To understand the system, you don't have to understand everything that happened, but you also have to understand what has not happened. And, you know, I'll just also bring up a point, like, this is the first time I'm giving this talk, so the number of times I've started this talk is 1. But how many times have I not started this talk? I mean, is that even a thing? I mean, how do you count such a thing? Let alone compute the implications of me not starting that talk. Whatever number of times I have not. How can you possibly compute the effect of that? Here I'm going to dump on the many worlds hypothesis. So, you know, Brian Greene, forgive me for this, but this needs to get done. You look at the solar radius there in meters, about 700,000 kilometers. The measurable amount of light, the time it takes for a photon to diffuse its way out of the core of the sun to the surface and escape is, some predictions say 100,000 years, other people say it's only 20,000, but it doesn't really matter for this application of the talk, so I'm not, don't want to quibble about the precision of the numbers too much. But I, given that effect and, the power output of the sun and the number of, how many are leaving per second and how long they're trapped there, you can calculate the number of photons rattling around in the sun is on the order of 10 to the 58th power of photons currently in the sun that are bouncing around like crazy, with a mean free path of just around 1 millimeter on average. That 1 millimeter, creates about 3 times 10 to the 7th collisions per second, scatters per second. And so the number of photons scattering per second is 3 times 10 to the 69th power. And if you go to 100 billion galaxies, each with 100 billion stars, which is kind of a minimal number for the observable universe, you have around 3 times 10 to the 91 photons interacting in stellar furnaces per second. And the many worlds hypothesis says that each scattering creates a universe where the scattering has occurred and another alternate universe where the scattering has not occurred. So our individual universe in the next second will spin off approximately 3.5 times 10 to the 91st other universes. But it gets even worse because there's also a factor called B, which I haven't gotten to yet, but here I am getting to it. So the number of universes created since the Big Bang would be, it's not just 10 to the 90, 3 times 10 to the 91st, but all the universes we're spinning off are creating their own universes. So it's an exponential growth term. So you have e to the a per second, and your top exponent is the number of seconds since the Big Bang. That might be a low estimate from the James Webb Telescope. People talk about the Hubble constant, how fast the universe is expanding. It's not really a constant. They called it a constant originally because they thought the universe was eternal and steady state. That's not the case. So it's really a Hubble frequency. It's a function of time, and the Webb telescope is suggesting it might also be a function of space, that the universe is not uniform over large distances. The expansion rates might also be a function of space, not just a function of time. So all these are implying the universe could be older than our current estimate of 13.8 billion years. But B is here in this equation too, and B is all the interactions that did not occur. We're assuming our universe is the top dog. It's only when we have an interaction that we spin off another universe. But no, what about all the probabilities where we're on the receiving end of the non-interaction? And how do you calculate that? I don't know. How many times does something not occur? But it's got to be huge. So it just seems absurd to think of, the number is beyond comprehension. You can hide any finite concept in an infinite number. So the physicists that are proponents of the many worlds theory are quite happy to ignore the fact and just say it's a really, many really means quite a lot, but really not dive into the implications of somehow we're creating so many universes on the fly, and every second it's that we're in existence, we're going up by 10 to the 90th more, e to the 10 to the 90th more, plus b, which is even a huge number compared to what we've already got. It just seems absurd. The mathematics behind many worlds is very elegant. My position is it's a trap, a very well baited one, but it just seems like an absurd concept. Oops. Photon interactions. I don't know how familiar some of you might be with the principle of least action. It's the kinetic energy minus the potential energy of a system is called the Lagrangian of the system. You integrate that over time, and that's the action of the system, the action integral. For a photon, its energy is a constant. If you haven't had an interaction, so that the Lagrangian comes outside the integral, and the action is just the energy of the photon times the time difference. And the principle of least action is the photon will always demonstrate the shortest path between its emission and its absorption. It's similar to the lifeguard situation where a person's drowning over here and the lifeguard is over here, and this is the beach, and this is the ocean, and there's a ratio that the lifeguard can run faster than he can swim. And so he doesn't take a straight line to the person. He can actually get there faster to the drowning person by taking the path of least action. This path would, given the ratio between running and swimming, let's say this is the fastest way he can get there. That's the path of least action. And photons demonstrate this. And it also proves that, you have to believe the QED of the basic model is you have an emission of a quanta of light, and there's a growing sphere of probability. The wave function is a complex numbers. Complex numbers are not probabilities, but the complex conjugates of them are real, and in the mathematics, that complex conjugate is a real number, and it represents the probability of where the photon is. And it's not that we don't know where it is, it's the fact that it's objectively undetermined where the photon is. It's in this sphere of possible influence, and you might get slowed down if you're going through a medium with an index of refraction that is, greater than vacuum. The photon slows down, but the probabilities always line up that, if you observe the emission and the refraction, the photon has taken the optimal path to get there in terms of the time it took to get there. So the experiments are validating QED. And there's just so many experiments that are validating this and are suggesting different effects compared to thinking of light having an equation of motion of moving from one place to another. It's quantum magic. You got the light there on the ceiling, and I have my hand, and I put my hand here, and I get a shadow, and it seems like light is coming down and hitting this hand, so it creates a shadow, and that's not exactly what's happening. It just isn't, because you can make a model like that and it works for this, but there's other physical effects that model breaks down. Diffraction gratings, quantum tunneling, this is how semiconductors work. You can't explain semiconductors working with a model of light, and I'm not talking about visible light, I'm talking about the whole spectrum. You can't explain that, how a semiconductor works with a model of light moving through the air. You have to bring in quantum tunneling. And you sure as heck can't explain quantum entanglement with a model of light moving through the air, where photons can be correlated with each other across any conceivable distance. It's a non-local universe we live in, where effects are not just generated by local effects. It's proven. So here's where I'm branching off into some wacky conjectures. that the quantum mechanics is a well-developed field. It's a field of complex numbers, uncertainties, probabilities, and the equations are computable in QED. Light obeying the principle of least action, the past is objectively undetermined, and the quantum mechanics equations are linear in time, which means you can run them back and forth in time. Time doesn't really matter to the fundamental nature of the equation, the direction of time. In the classical world, at the bottom, a well-developed science, classical mechanics, a domain of real numbers and certainty, computable, self-organizing phenomena. It's infinitely sensitive, so you can diverge with your computation, but the effects are computable. Objects obeying equations of motions, the planets orbiting. The past is immutable. If I break a table, I might be able to decide to repair it today, but I can't change the fact that the table was broken yesterday. And also the dynamic equations are linear in time. And it's a missing science how to connect these two regimes. People have created the words collapse of the wave function, and they're assuming their job is done. In the quantum world, you have wave-like properties, collapsing the wave function. The quanta is acting as a particle, and the science is not looking at this in any more detail. But what if it's actually a real piece of physics that's connecting these two? And I call it the interface mechanics. This is just my conjecture at this point. And I think of it as the reality creation process. What's the process that turns an undetermined past into an immutable past? It seems to be occurring. What is the physics behind that process? Not just slapping a phrase of words on it and saying, the job is done. Understanding, how that process works. How do you turn an undetermined past into an immutable past? And just from ideation about this process, it might be a time asymmetric physics, because if you think about it, you have this immutable past, you're running backwards in time, it's time to create an undetermined past, but which undetermined past do you create? You've got this interaction, which is on the sphere of probabilities, but you don't know the radius of that sphere. The radius of that sphere is gone. So I suspect that you can't run the equations backward in time across this interface. So my conjecture is it's a time asymmetric physics. And my central thought of this talk is if this process is incomputable and self-organizing, is that the reality creation process? Qualities of consciousness. If consciousness were computable, you couldn't be held accountable for your decisions. Going back to the psychology, you can't hold an algorithm accountable for its convergence. You're not accountable for which universe your many worlds have thrown you into. You can't hold the numbers 3 and 4 accountable for failing to sum to 8. That concept makes no sense. How do you hold the number 3 accountable? How do you punish a child? You take away its toys for a few days. How do you punish an algorithm? Take away its vector database, make it print out, I must do better 1,000 times on the printer. Does that concept make sense? Here's an indication where I'm saying, consciousness is not computable. Actual physics or magic. You've all seen magic shows, right? What's a standard repertoire of a magician? Making something disappear. It could be a playing card, could be a coin, glass of water. Maybe if you're really good, you can make an elephant disappear, right? But, what has the magician actually done? Has he actually taken a sledgehammer to the laws of physics? Because, if he actually managed to do that, you've destroyed the conservation of energy and linear and angular momentum. You destroyed time's arrow because you've made a major reduction of entropy in a closed system. You destroyed the concepts of Lagrangians and system Hamiltonians. Has the magician actually done all that, or has he just created the illusion of doing that? So my point is, I think Turing missed the point with his imitation game in the 1950, that he didn't consider it's not just the evidence of a mind, it could be the illusion of the evidence of a mind, talking with a computer program and not knowing whether you're talking with a person or a computer. Creating an illusion is not the same thing as actually doing something. Paramecia, this is again something that's described in Roger Penrose's book in more detail, but really interesting experiment in the 1990s, and it's been ignored ever since. They could actually teach paramecia and train them to do things. They had a number of different jars cycling water temperature at aperiodically, and each jar would have a certain temperature that the paramecium would be fed with. And then they trained the paramecium that this is the temperature where food is available, and then they stopped feeding them. Sounds cruel, but they're single-celled animals. But they were swimming around like crazy when their feeding temperature was there, even though there was no food. There was no chemical signature for food, but they're still swimming around like crazy searching for bacteria to eat, because that's what they're hunters. Paramecia are hunters, they eat bacteria. And they were just sort of drifting around, not doing anything when their feeding temperature was, their temperature was a different temperature than the feeding temperature they'd been taught. So this is a paramecium that had memory in its history of when food was available and was making decision of how to act based on that memory. I mean, that sounds like consciousness to me. And it's a single-celled animal, no neurons. What it does have is its entire surface body covered with carbon nanotubes filled with pure water, just connecting, dead ending in there. And you have to think, life is efficient. Why is it bothering to grow, tens of thousands of carbon nanotubes filled with pure water if it doesn't need them? But that's what the paramecium has. In the human brain, there are lots of neurons, but there are thousands and, hundreds of thousands of times more carbon nanotubes filled with pure water than there are neurons in the human brain. The human brain cells are very furry, lots of carbon nanotubes. Life is efficient. Why is it growing these carbon nanotubes? Looking at the element of xenon, an inert gas, it can be used as an anesthesia. And it's somewhat puzzling from a physics perspective because it's a noble gas. There is no chemical interaction. But the single atom of xenon is so big, it could lodge itself at the end of a carbon nanotube and interfere with the standing wave resonance of the water inside that carbon nanotube. A single atom of xenon can do it. These carbon nanotubes are so small, and the xenon atom is so big. It can interfere with a electrical wave resonance inside these little carbon nanotubes. There's also the knowledge that carbon nanotubes don't just have to dead end, they can actually connect neurons. And there is established connections and electrical impulses between neurons can be transmitted by carbon nanotubes. So my conjecture is we actually want to reverse the concept. Rather than thinking of the neurons as the main seat of consciousness and the carbon nanotubes as conductors of electrical impulses. My core theory, and I'm just putting this out there without any definitive evidence, is that there is a large-scale quantum resonance in the carbon nanotubes that is the reality creation process, that is the creation of thought. And the neurons are working as routers to push the ability of this resonance far beyond what a paramecium has. I mean, the paramecium has it's the surface of its skin, being able to conduct and coordinate the quantum resonance inside these carbon nanotubes. We're much more evolved with our neuron networks to make this quantum resonance much more capable. And another reason I think this is true in terms of actually locking our ability to be accountable is that in order to compute what this quantum resonance is doing, since it's at the interface layer between uncertain past and an immutable past, in order to compute the effect of the stages of this quantum resonance, you'd have to know not just what has happened in the past, but what has not happened in the past, all the counterfactuals. And how do you even count those counterfactuals, let alone compute their effect in a self-organizing phenomena? So, final thoughts on computers and thought and the way humans think. Computers have evolved to a point where their abilities, to me, seem completely complementary to what humans can do. I mean, nobody wants to compete with a computer for finding roots of equations, for sorting, joining data, for filtering data, to search parametric space. Computers are much more efficient than humans in doing these things, and their logic is computable and rational. On the human side, we have the ability to create algorithms, which intrinsically has to be a non-computational process. The ability to ideate, out-of-box exploration, the ability to doubt. I remember once, 1990, at Bell Labs, one of the researchers there was building a decision support system and lamented the fact that he couldn't teach the algorithm how to solve problems he hadn't taught it how to solve. And you can see on a logical basis, the obvious contradiction of that. If I taught it how to solve the problem, then But hopefully teachers do this all the time. And I think that one of the key ingredients is the computer can't doubt the program it's running. The students can doubt what the teacher is teaching them. If you filled a large language model database with Newtonian mechanics, you're never going to get general relativity out of it, because that's ideation. That's Einstein rejecting what his high school physics teachers were teaching him. There's flexibility with humans. The value is not visible until it's needed. So you have a process being developed and management wants to automate it because keeping the development staff attached to the project is a lot of money. But once you've done that, you've taken the flexibility out of the system. Humans, the logic is incomputable, and it's both more and less than rational. Final thought, the AI systems have had superb successes with time-independent systems. Listening here, but where are there successes with time-dependent systems, such as a marketplace? And thinking of the process improvement engine of research and development driving operations, operations collecting and driving what quality and assurance issues are, and those quality and assurance issues driving the R&D, and just keep running that process, cycling through the process improvement engine to stay in business and improve your product or service. Who or what should be running that process? The computers or your people? One final thought here is humans thinking being both more and less than rational. The human expression of compassion can be so beautiful that it transcends rational thought. And the human expression of hatred can be so malformed and misguided that it transgresses rational thought. And my position is that neither of these expressions is the result of converging algorithms. And one epilogue slide. I've written a novel, Trial by Fusion. It's a story of two species, one human, running an experiment to see if they can merge into one society. And if you like science fiction, and you can get this book on Amazon if you're interested. It's a good story. So, open up for questions.
So consciousness is a very intriguing topic, and I'm of the belief that if we want to make progress in any field, we need precise definitions. This has certainly been the case in mathematics, but as you point out, it's very difficult to come up with precise definitions for many of the terms that you are using, like thought or ideation and so on. But let me ask a very specific question related to reactive distributed systems that maintain an ongoing interaction with their environment. So systems like the internet, perhaps the human brain. But do you think there is a model of computation that's universal in the same sense that the Turing machine is a universal model for algorithms for these kinds of systems?
Yeah, I think I do believe consciousness is a physical process. It's got all the key signatures of about I think it's 2/3 of the entropy your body's producing is used up by the brain. And that's the grand design of cosmology. You have entropy and self-organization thriving in each other's counterflow. So the body's doing a lot of work to support the entropy production that's occurring in the human brain. The universe is filled with self-organizing systems. You can create one on your kitchen stove. You put a pot of water to boil, and it's not happening anything too exciting, but you crank up the heat to full, and you might start getting a convection roll. The water molecules are self-organizing into a coherent wave. How do they do that? Tornadoes, if you have a fan and you turn the fan off, the wind dissipates, but a tornado self-organizes into a very discrete system, doing a tremendous amount of damage because it's so concentrated. I think the greatest self-organization feature of the universe is life. An acorn, will throw it in, plant it, and it self-organizes some nutrients in the ground, but also mostly the water and carbon dioxide, and it organizes that into an oak tree. How does the acorn do that? The evidence for self-organizing phenomena are all around us. The thoughts seem to organize themselves. It seems incredible to think that it's just algorithms and we're just crunching a deterministic path with crunching an algorithm in our brain and living with a many worlds universe where the free will doesn't exist. It's a basic choice to make whether you think free will is an illusion or is real. On my side, I've never seen anybody act as if they didn't believe there was free will. Even Brian Greene, who's a great proponent of many worlds philosophy, he acts like he believes in free will, even though his mathematics says it doesn't. I'm not sure I answered your question, but that was the best I could do.
Thank you.
Okay.
You'll have to stay here probably. Thank you for this amazingly stimulating talk. And it was like a tour of all the different ideas about consciousness. When you talked about a single cell learning and making decisions, and that looking like a form of consciousness, I could relate to that. And then you could envision a higher and higher complexity level of consciousness leading up to the consciousness that we're familiar with. That didn't seem so hard to understand as a broad concept. But when you talked about quantum mechanics, I was bewildered. If we have this vision of multiple levels of consciousness from the very lowest to a higher level, why do we need to turn to quantum mechanics for any insight? None of that seems to have anything to do with quantum mechanics particularly. So can you articulate why, when people write about consciousness, why are they always talking about quantum mechanics?
Well, it's getting back to the idea of thinking of consciousness as a physical process. And I don't know, how do you prove the non-existence of something? But I don't know of any physical, classical process that you couldn't simulate on a computer. So, in my talk, I'm tying it into quantum mechanics because to think of having a self-organizing system where its past is dependent both on what has happened in the past and what has not happened in the past due to counterfactual observations. There's no class, this is a solution to Schrodinger's cat paradox. And he put it out as a paradox. He didn't put it out as a prediction. Erwin Schrödinger in the 1930s. He put this out as a paradox and saying, somebody's got to explain this. This actually explains this, that the undetermined nature doesn't make it through the interface layer. The interface layer is the reality creation process, where you take all this undetermined past and you turn it into an immutable past, you turn it into reality. Where before that, in the quantum level, it's all possibilities flying around.
Good morning and thank you. You mentioned Schrodinger's cat, and it was my understanding that Schrodinger posed that thought experiment initially as a joke, that he was trying to describe how absurd all these notions either seem to be or are. You mentioned in your talk that nanotubes, which are already created, could be responsible for the creation of reality. That confused me. You mentioned also this whole notion of classical versus quantum, where in quantum the past is undetermined, but in classical it's immutable. That seems confusing. And I think one of your first slides, you mentioned 4 things. The first 3 were all kind of physical in nature. The fourth posited that there might be some non-physical component, that consciousness might have some non-physical component. And so my question then is, given all these seemingly confusing and contradictory things, might our set of assumptions that are driving our science be the cause? And could they use some further scrutiny? And is there any work being done on the idea, for example, that physics is not the genitor of consciousness, but the reverse?
I don't see any evidence for option 4. All attributes of consciousness, even at the human level, seem to be vulnerable to physical effects. Your memories, your mood, your desires, your cognitive abilities to process information, all of those are susceptible to physical brain damage. I can't think of an attribute of consciousness that is not susceptible to physical damage of the brain. And so just from the principle of simplicity, cut out what you don't need. What you can do with few assumptions, you do in vain with more. So that doesn't prove it, but I don't see any evidence for it. Maybe you could be right. Maybe it is something even more magical than quantum physics. But there's no evidence for that.
Thanks. That was a great talk. I've got a question for you. When you talk about time, they always say it's the arrow of time. It only goes in one direction, and that's because of entropy and a bunch of other things. But from what I understand, the mathematics and physics is that you should be able to go backwards in time. Is that correct, or is that a thought? Because if it works one way, it should work the other way.
Well, you would think it would require a time asymmetric physics, and I'm proposing that the interface layer is a time asymmetric physics. In regards to space-time, we have to stop thinking of space-time as a coordinate system. It's a fabric that you can stretch and twist and even put torque on it. It has a positive energy density and a negative pressure from cosmology and astronomical observations. This is not just a coordinate. You can use space-time as a coordinate system. But to think of actually traveling backward in it, it makes for great movies and science fiction books. And I am a proponent of science fiction books, but I don't see how you would get away from the infinitely deep physical paradoxes that you could create if you could actually do that. Unless you're just throwing off many worlds in the past or something. If you believe in the many worlds theories, maybe you can hide the mathematics of the paradox in that. To me, appearance of paradox is diagnostic that I've built the wrong model. And it's call it a faith statement, that there are no physical paradoxes. God did a better job than that in creating the universe. And it's our fault if we have cognitive dissonance and we're happy of holding contradictory beliefs with ourselves. The word paradox, it comes from the two words in Greek, para and digma. That's why there's a G in paradigm. Para is the Greek word alongside of, like two parallel lines running parallel to each other, never, side by side. And digma is opinion or belief. So dox is opinion or belief. So paradox is two beliefs riding side by side, never touching each other, never interlocking. It's another one of my faith statements is that truth will always interlock with itself. There are no physical paradoxes. It's just that we build the wrong models. And there's a lot of examples of that in human history, where people have just built the wrong model and gotten into trouble because of it. Because, you step away from reality, and reality has a tendency to come back and bite you for doing that.
So I'm not a scientist. I have no, math or background or anything else. So, and I have to admit, I was confused by a lot of what you were saying. It was over my head. So I'm just asking this question. So, if what you're saying is that that consciousness is some physical element, and that at the end of the day, a formula could come up with explaining what that is, then does that mean that you could then take that formula and embed it in robots so that robots would have a conscience as well?
I wouldn't say formula, because formulas can be computed. I would say physical process rather than formula. And if you understood the physical process, could you actually create a device that was physically conscious? The possibilities are open. Maybe if in quantum computing, if we allow the qubits to self-organize, would that be conscious? Open question. I mean, they're not doing that now.
Was that part of what you were trying to say, or was that?
Yeah. The idea is for ideation, there's no formula. It's just self-organizing, incomputable.
Anybody else? What a remarkable talk. Absolutely. Bill?
Well, Rob, the old guard has two ways of thinking, speakers. First of all, I thought it was a wonderful talk, and I understood maybe half of it, so I think I'm doing all right. But I took notes, and we can talk later. Our first way is the certificate of initiation. You'll notice there's an orchid on the certificate, and that's because when this organization was founded in 1930, believe it or not, it's another paradox. Summit was actually the U.S. orchid capital of the world. I mean, the industry was here. And the second way we have is an old guard salute.